Hey, welcome. Have you ever really stopped to think about how we learn to think like a scientist? Because it's not really about just memorizing a bunch of facts, right? It's about learning how to ask the right questions and then figuring out how to find the answers for yourself. So today, that's what we're doing. We're going to climb a ladder, the ladder of scientific thinking, and see exactly how this whole process works.
You know, when you picture a science class, what comes to mind? For a lot of us, it's one of two things. Either you're picturing students just, following a super rigid recipe-like procedure, or it's the total opposite, complete chaos, with kids just kind of mixing stuff together to see what happens. Well, the source material for today's explainer suggests there's a much better way, a more structured path that leads to some real, genuine discovery.
So, there's this big idea in education called inquiry-based learning. And it's a fantastic concept, right? Students learn by investigating things for themselves. But in the real world, it can be super tricky to pull off. A lot of teachers find it hard to even nail down what inquiry really is, let alone how you're supposed to design activities that actually build those critical thinking skills in students.
And that's where this idea comes in, a really practical 4-level framework. The best way to think about it is like a ladder. Instead of just throwing students into the deep end of open-ended discovery, which, let's be honest, can be super frustrating, they get to climb step by step. They build their confidence and their skills all along the way.
Okay, now this table here really lays out the whole journey so clearly. Look at level 1, confirmation. The teacher gives you everything right down the line, the question, the procedure, and the solution you're supposed to get. But then look at level 2. The first real shift happens. The student is now the one who has to find the solution. And as you keep climbing that ladder, you can see more and more of the responsibility shifts over to the student until you get to level 4 where they are completely in the driver's seat.
So let's see what this actually looks like in a classroom. Now, level 1 is basically just confirming something you already know, like a cookbook lab. The real learning journey, though, it kicks off on that second rung of the ladder, structured inquiry. And our first case study is a really fun one, the mystery of the dancing raisins.
Okay, so picture this. A teacher just pours some club soda into a cup, drops in a few raisins, and then something really weird starts to happen. The raisins, they start to move. They sink down, then they float back up to the surface, and then they sink all over again. It's a really simple, kind of puzzling little thing that just immediately makes you go, huh.
Now remember, we're at the structured inquiry level, so the teacher provides the main question. And here, it's super direct. Why are the raisins doing this? See, this question gives the whole investigation a focus, a direction, but it leaves the how and the why, the explanation, totally wide open for the students to figure out.
And almost immediately, the discoveries start happening. Students are watching closely, they see the little bubbles clinging to the wrinkly raisins, and they start making connections. One student even suggests they're becoming less dense. Now, she might not be able to give you a textbook definition of density just yet, but that's not even the point. The point is, she's starting to use scientific language to explain what she's seeing. The reasoning process has officially begun.
And then you get the aha moment. After a little discussion and more observation, the students piece it together. The raisin's mass doesn't change, right? But all those bubbles clinging to it add volume. They make it take up more space. This lowers the raisin's overall density and poof, it floats. Then the bubbles pop at the surface, it gets dense again, and it sinks. It's such a clear example of how students can build a pretty complex concept all on their own.
All right, so the students have a pretty good handle on the basics of density now. So, it's time to climb up to that next level of the ladder and see how we can deepen that understanding. We're now at level 3, guided inquiry, and we've got the soda can mystery.
So the teacher presents a brand new puzzle. 2 cans of soda that look, for all intents and purposes, identical. They're placed in a big tank of water, but one sinks like a rock, straight to the bottom, while the other one just floats there. It's a totally unexpected result that immediately gets the students asking the guiding question for themselves. Why is that happening? Now, here's the big shift in guided inquiry. The students get to design their own procedure. They decide how to investigate this. So they check out the cans, they figure out the volume is the same. They decide they should probably weigh them, and boom, they find the key difference. The can of regular soda has more mass. They aren't just being told an answer, they're figuring out how to find the answer. And this leads them to even more cool experiments. One student started wondering, well, what if we made the water denser by adding salt? And the explanation that comes next is just amazing. This student now gets the density isn't just a property of an object, it's a relationship between the object and the liquid that it's in. I mean, that is a huge leap in understanding from the dancing raisins.
So,
After mastering those structured and guided investigations, the students are finally ready. We've reached the summit of our ladder. Level 4, open inquiry, where they get to act like actual scientists.
And the setup is beautifully simple. Tubs of water and just a cool collection of random objects. An apple, some clay, different pieces of wood, an orange, and that's it. There's no guiding question from the teacher this time. The only goal is to explore, to play, to just let your curiosity run wild. And the result of this freedom? It is just incredible. The students start generating their own I wonder questions, and they are so insightful. I mean, look at these. They're not just answering questions anymore, they are asking their own. My favorite one? I wonder, will an orange still float if you remove its peel? Now that is a testable, insightful, and genuinely scientific question that was born from nothing but pure curiosity.
And just like that, the journey up the ladder is complete. These students have gone from simply confirming a known result, to figuring out an explanation, to designing their own experiments, and finally to asking and investigating their very own original questions. They've literally transformed from being passive learners into active scientific thinkers.
So yeah, this is obviously a really powerful way to train future scientists. But let's end on a bigger thought here. What if this isn't just about science class? What if this ladder, this whole process of learning to observe, to question, to investigate, and to explain, what if this is actually how we train critical thinkers for any field? What if this is how we teach ourselves how to solve any problem we might ever come across?